Dobrodošli. Ovo je Phoenix kanal.
Here's a question for you. Can we predict the path of a total solar eclipse using just 2 moments in time? Sounds impossible, right? Well, with some big eclipses on the horizon, this is a good time to check it out. In 2027, popular tourist destinations like Morocco, Tunisia, Egypt and Saudi Arabia will all be in the path of totality. A year later, in 2028, it'll cut right across Australia, travelling through Sydney before speeding its way over to Dunedin on New Zealand's South Island. Before we look at the globe model, let's quickly test the idea in a flat earth type setup. At 1:33 UTC near the start of the eclipse, the Sun and the Moon are directly above these coordinates. By 4:18 UTC near the end, they're directly above these ones. That journey takes about 9,900 seconds, so we can split it up into 9,900 individual steps, like so. Now, unlike the globe, nobody knows the heights for the Sun and the Moon in a flat earth model. But one thing's for certain, the Sun must be higher than the Moon for the Moon's shadow to reach Earth. Whenever that happens, we can draw a ray from the Sun through the Moon, and our shadow point is where this ray hits the surface. Since we already know which places will experience totality, I've manually added these points for reference, and joining them together we get a path, something like this. Let's see what happens when we run the trace. It's not looking too clever, is it? And it should go without saying that there is no combination of Sun and Moon heights that can result in anything like the correct path being traced out on any flat earth map. Now let's try the same experiment on a globe. Same times, same positions, but this time we'll use the known distances to the Sun and the Moon. Again, the journey is split up into 9,900 steps, and these are the places we know will be in the path of totality. So let's run the animation and watch how this one plays out. So not only did the path of totality match what's going to be observed in reality, the times matched too, right down to the minute. Now let's take a look at the 2027 eclipse before we make some conclusions. So with nothing more than 2 snapshots in time and the basic geometry of a globe, we can predict the entire path of totality, thousands of kilometers long, and match the timings to within a minute. On a flat map, there's nothing that can come close. On a globe, it's simple and it works first time. If you'd like to try this for yourself, then you can enter your own values here. You could try entering the details of a past eclipse and let me know how you got on. So that's another win for the globe. Don't forget to hit that thumbs up for me if you can. Thanks very much for watching, and I'll catch you later.
Produkcija Feniks kanal.